Kicking it off this afternoon, we have Caleb Roberts talking about motivating large-scale resilience management on working lands, and you can tell us the rest.
Okay. Yeah, sorry for the long title. You can blame Direct for it. Okay, so my name's Caleb Roberts. I'm a postdoc at University of Nebraska. This is a sort of synthesis of work of mine and Direct's and Daniel Uden's and Dylan Fogarty's and Craig Allen's. But I would be remiss if I didn't thank all the folks specifically down there, Brady Allred, Matt Jones, David Noggle, Jeremy Maestas, Tim Griffiths, Ted Heater, who are working on this with us, and then, of course, all of our cooperators and funders. I'm going to especially shout out to our private lands groups, because we're going to be talking about that mostly today on the private lands, the Les Canyons Rangeland Alliance, and the Sandhills Task Force. And also the Twidwell Lab. I was paid to say that. He's my boss. Okay, so what I'm going to be talking about today is sort of using this as an outline. So this is an approach to large-scale private lands resilience management and planning, right? It says it right there. But I'm just going to walk through this in the beginning, and then we're going to see this approach built from the ground up in two different ecoregions. So we'll see examples. And then we'll see what we all came here to see, the outcomes and cool things of what's coming from this. Okay, so this planning sort of schematic has four elements, right? We have sort of starting with the private lands management data. This is crucial. It tells us, of course, what's actually going on in the landscape, so we don't have to guess. We can actually see, and we work with the private landowners to get that. This is notoriously difficult data to get, right? It's very difficult to get private landowners to give you information about what they're doing on their land because that's their choice. What we're going to be talking about is to build the so-called street cred, right, to be able to get that. And then what comes out of it is being able to use the next element, which is this cross-scales systems data. This is the stuff that ecologists have a lot more of, right? We have ecological data. And what I mean by cross-scale, though, is stuff that from what we see at the feet, like what Joe was talking about this morning, all the way up to the stuff that scales out to the biome. So data across all those scales. And we'll be talking about two sort of data sets that are the cruxes of that approach. And the third element essentially takes the first two and combines them, right? So we see what the management is happening. We see the ecological data, and then we use those two to understand what are the outcomes of this management, right? And we look at, we're going to talk about different aspects of those outcomes. This is indelible, right? Because not only does it make us feel good about what we're doing, it tells us what we're doing right, what we need to improve on, and most importantly, it gives us success stories. And success stories help us build into the fourth element, which is this co-production of science, communication, and management, right? So we're able to tell those success stories and build the network. We get more people buying in. We get more scale to this. And then we can get more private land management data and build this cycle that keeps on going, a big machine, right? So walk through this. Part of the title of this talk is motivation, right? So I'm going to motivate you in the way that ecologists love to motivate themselves by telling you awful stories. So the first awful story is the great transition of the sagebrush biome. Okay, so we know that cheatgrass is invading into the sagebrush biome, right? It's causing a state transition. I like to call it a regime shift, whatever. I'm just going to say transition, though. It'll be a more neutral term. And it's happening at the scale of a biome, right? So this map is the sagebrush biome, approximately. And what we're seeing here is actually, this is mapping out where those transitions are happening in space, where the sort of yellow to red are the strongest boundaries of the cheatgrass or annual grass boundary with the shrub, which is sagebrush, happening in 2000. And then 2017, we see it. It doesn't look great here. It looks even worse here, right? It's gotten bigger. It's expanded out. And I'm not going to talk about this data set yet, but if you're tantalized, keep listening, because I got to move on to the thing I'm going to be focusing on the most. That this was just to sort of orient you. This is happening right here. But it's also happening in another place, so more bad news. This transition is also happening in the Great Plains, right? In the Great Plains, however, it's a transition from grasslands to woodlands. And of course, 2000, this is the sort of extent of the grass tree boundary. It's kind of ballooned up a lot, hundreds of miles in 2018. Of course, this is just this classic resilience ball and cup showing where we are in the state. And it's moving into the tree state, right, for the whole biome. Why am I telling you these awful stories? Because I want to motivate you with that whip of guilt, but I also want to sort of move into this other idea of we are talking about this because we don't want to have those transitions happen, right? At large scales, we don't want these transitions to happen because we want to stay in this regime or state and not be in this one because we like all the ecosystem services that this state provides us, right? With wildlife, with livestock forage, economic benefits, water resources, and we don't want to lose those, and we don't want to have the negative impacts of moving into this other state. For instance, increased wildfire risk in the case of woodland states in Great Plains. But how do we do this? How do we stop it at the scale of a biome, right? That's a huge question. These are insanely large pieces of land. I mean, we're talking about like third, fourth of the country. How do we enact management that scales up to those levels? Historically, we've lacked those tools that scale up. What do I mean by tools that scale up? Let me give you sort of an example that tells you what I'm talking about. So in the Great Plains, right, tree, grass boundary down here, more intact grassland up here. Those years, 2004, 2008, there have been millions of dollars spent. There were millions of dollars spent on brush management in the Great Plains, and they focused mostly down here. But what happened about a decade later, it got bigger. The problem got worse. So what we were doing was we were focusing on chasing these transitions, working in the most affected areas. And I like to say it's like bailing water out of a sinking boat with a spoon. So we've just bought a really expensive spoon, but we're not seeing any benefit of it. So how can we instead adapt our management? And this is a private land dominated biome, right? How can we do that in private lands to halt these transitions? Well, we've got some good hints. We got some good motivation coming. So we're getting out of that negative land. We're going to get into positive land. And I'm going to show you the outcomes, the positive outcomes from 2 ecoregions in Nebraska, because that's where we work with private landowners the most. The first is in the Les Canyons. It's about right here. It is in a tree state. It was a grassland state, and it transitioned broadly into a tree state. There are some grassland patches, but these ranchers out here are feeling the heat of this problem, right? I'm also going to be talking about this other ecoregion, the Sandhills. It's quite big, but it's sort of the biggest intact grassland in the lower 48, right? It looks great, except so it's in the grassland state, but it's got this incipient invasion, right? This little tree peeking out here is just sort of a hint of what's actually happening. They're seeing the beginnings of this. So they want to keep what they've got, and they want to get rid of this problem, right? So these 2 ecoregions are coming from different standpoints, and we'll talk about the approach and the outcomes for both. But first, we're going to do the Les Canyons. We have the most history with them. We started working with them in 2014. That's about a 330,000 acre area. So I'm just going to sort of build this approach up. We've already talked about it. I'm going to go a little fast, but we're going to use the Les Canyons as kind of like a thought to place ourselves in this approach. Okay, so we're ecologists. I like theory. Some people don't, but what we're sort of building this approach around, sort of the supports maybe of it, is some theory, right? We've got resilience theory that's in the title, but specifically what we're talking about is a sort of offshoot of resilience theory, spatial resilience theory, okay? So several of the group is on this paper that came out in 2016, and it's just saying, look, we normally think about resilience in time, so a ball moving to another basin of attraction in time, but there are spatial attributes to resilience. They talk about that and review that in this paper. Then we have this paper that we put out in Nature Climate Change this year. This paper is saying that, look, those spatial attributes, we can actually say, look, there are actually boundaries to regimes or states, and we can know where they are, and we can track them in space and time. What does that mean? For us, large-scale transitions have strong spatial order. That means they're tractable, and we can actually use that signal as a quantification of restoration and how we're doing in management. Cool. Let's not talk about the theory again, right? Okay, we're going to move on to the outcomes. So, and everything else. So for this approach, the private lands part, we talked about that. We're working in this area. These are management polygons. These are data of fires that they've done on their private lands that they gave us. This is huge. It's a lot of trust that they give us. And we're using it, hopefully, to a good effect, right? So we take this from the Les Canyon Rangeland Alliance, we combine it with our cross-scale systems data, all the stuff from our feet, the rangeland analysis platform Brady already talked about. I'm going to get into that a little bit more, although he did a great job, of course, summarizing it, or not just summarizing it, going over it very well. And then also a derivative of the RAP, which is the spatial transitions work I've been showing you, right? So taking that spatial resilience theory, using the RAP, and then sort of applying the theory in a way to track the transitions in space and time, okay? So I'm going to pause here and talk about the data very quickly. So the rangeland analysis platform is fantastic. It's summarized in this paper by Matt Jones et al. In Ecosphere. What it does is it takes Landsat data, it takes field plots from the NRCS NRI data, it uses awesome cloud computing stuff from Google, and then bam, magically, it produces this continuous vegetation cover data for various functional groups at 30 by 30 meter resolution from 1984 to ongoing every year after this one, right? So that is very powerful data, and it's across an extremely large area. So we can talk about monitoring at biomes, right? That's awesome. Now, what about this tracking transition stuff? That's a little bit more nebulous, so I'm going to give you a very, hopefully clear sort of thought experiment or a visual example here. So this is a aerial photo from the Les Canyons. Grass, trees. We can think of this as a tree state because these areas have spatial context. This is a regime in space, or a state in space of trees, a state in space of grass. So there's these two regimes or states abutting each other, right? If we use the RAP data and use some fancy spatial covariance raster algebra that Daniel Uden came up with in a paper that's in review right now, we can actually find the boundary between those two states, right? You know, we can look at it on a picture, but this is actually quantifying where that is. And we're seeing the areas with the the relatively high spatial covariance as areas of a more intact or inner area of trees. The very negative spatial covariance areas is this dark red is the transition zone between trees and grass. And this other blue area is the area where grass is covariating with grass positively, so you get a higher spatial covariance signal, right? So that's cool. Why do we care? We care again. I'm going to keep on saying this because what side of the line we're on determines what ecosystem services we are getting, right? In the tree state, if we go in there and brush manage it, that means that the tree seedling, this is data from Dylan Fogarty, he's still writing this up, but the trees are regenerating within a year. That means our conservation expenditures are going out the window. Whereas if we manage in this grass state, we're buying like up 12 years of time of our management to be useful. So that's why this matters. Okay, so we can track those transitions, or we can sort of map those out. That's pretty neat, but the biggest thing is adding time to that, right? So say we've got the Les Canyons. We're talking about that. Say we see a signal over here in this spatial covariance data, this transitions level data. If we look at it over time, say the signal is transient, flashing in and out, nothing really going on there, we're not worrying about it. Okay, well, what if the signal is actually persistent, but it just stays put and it's not moving? Okay, maybe that's not a big deal either. But the big thing is if it starts small and gets worse, or if it moves out, if it has that spatial context that moves out, that means we're losing ecosystem services, and that means we need to take a spatially targeted strike team and target these areas, right? This is the screening approach that Dan Uden et al. Are talking about in their paper. And again, why do we care about this? Because if we're on this side of the line, we've got low livestock production. If we're on the green part of the line, we got high stuff. So our ecosystem services are being like eaten up before our eyes, right? We can track how that's happening. Okay, so private management data, cross-scale systems data. All this feeds into how the management data is affecting all the things that we care about, the wildlife, fire risk, livestock, and water. In the Les Canyons, we have outcomes for livestock and wildlife and some hints about these two things, but I'm going to be focusing on these two outcome aspects. And all this, of course, feeds back into this co-production. It feeds into this loop again. And with all of our partners, we work together to say, what are we doing right? What are we doing wrong? How do we need to adapt? And then that allows us to scale up our management. Okay, so some outcomes. We have this private lands management data. They have been burning crazily in the last 18 years, right? And we know where it is. The most exciting thing that we are seeing is they are actually halting a transition. This is the RAP data changing over time on trees. Instead of it just going up, it's leveling out. Right about here, right when they're scaling up their management. This is one of the first examples of a tree grass transition being halted in the Great Plains. It's awesome. And we can see that this is a spatially explicit phenomenon. It's sort of matching where the management is happening. Okay, for livestock, we're using the new RAP data, which has productivity in it by functional group, to show this. This is actually field plot data, but after time since fire, we're seeing a 2,000% increase in productivity at the pixel scale. At the management unit scale, with the RAP data, we're seeing a 25% increase in productivity from the management data. And this is showing in the whole ecoregion that there seems to be an increase, although we don't know because of there's no replicability here, but we seem to see a trend. So this is really cool. This is huge. We're marrying the livestock and the ecosystem services. I'm going to buzz through this really fast. This is our paper. We're saying that this method is able to track transitions in time. And this is just an example with the bird showing it. But what if we sort of use this idea of combining our bird data with the transitions data? This is something I'm working around right now. I'm very excited about it. This is the transitions data. This is overlaying bird BBS data and looking at transitions with that, with the RAP data. We're seeing that the birds are corroborating with the vegetation transect. So if we can, or transition, so if we can map those together, we can actually see how the birds are being affected in space and time by our management. So this is a cool thing that we're looking into doing. But the most tangible benefit is with the American burying beetle. It's got one of its last bastions in the Les Canyons. And look, we're overlaying it with the spatial covariance data. The size of these dots more or less correlates to the population abundance of these beetles. They're mapping with the transitions, right? An endangered species is corresponding with these transitions. That's awesome and huge. Okay, the sandhills. We have less going on here because we have less history with them, but I'm going to talk about what we have, which is a spatial transitions data, right? So it's coming right up to their doorstep, and in fact, it's in their area. It's coming. Traditionally, we focused on these areas and sort of left these areas alone for management. But with them, we're going to start this new approach and experiment with them, with flipping this. Deprioritize the areas that are hit and reprioritize the core areas. What this looks like is actually doing a plan of management that scales, taking a huge amount of land, maybe 500,000 acres. That's what we're trying to get a coalition together to do. Building a core where they intensively manage, and then on the edges, all they have to, because the seeds come in from the edges, right? If they intensively manage the core, all they have to do is help neighbors to manage the edges, and that's much less land. So this is an ongoing thing, and we're excited to keep on working with them on it. So I'm running out of time. Take-home messages. 1, our approach builds trust and a shared vision. We get the private lands management data because we have the trust with the landowners, and that feeds into this next approach, which is these novel methods and tools, being able to empower management and science on real-time scales. Then we can track the outcomes and tell the success stories and adapt in real time, and that feeds into building the network, a lifelong partnership with these people, right? But the biggest thing, the thing that we're most excited about is this approach is working, right? It is halting large-scale transitions like in the Les Canyons. It's working to have real results on huge scales, right? So again, thank you all for all the partners of working through this process, and I will take questions if I have time.
We've got a minute while I switch presentations. If anybody got a question for Caleb?
So the question was, what is the private lands data that we have? Right now it is, yes, where they burned and when they burned. Exactly, yes.